So hello, everyone. All right, everyone here looking for a shrinking production instance. We're going to talk about how to keep outages from affecting your users and keeping them happy and keeping everyone happy. So whenever you go to a talk, you generally want to know, who is this person and why should I spend an hour listening to them? So who is Mike Taylor? Well, he's me. I spent a decade or so building architectures and services for companies large and small. And then I got interested in this newfangled thing called DevOps. So I came on board at Google as an SRE. And I've been an SRE on call for Google Cloud for about 3 years now. And in those 3 years, I think I found more about preparing for, mitigating, and avoiding production incidents than I had in my entire previous career. So I'm here with you today to share some of the best things I've learned about production incidents, or as we usually call them, outages, and how to shrink them. But first, it's important to cover why I'm talking about production incidents and how to shrink them. The head of Google Cloud Customer Reliability Engineering, Dave Renson, who you may have seen walking around here, he always says that reliability is your most important feature of any service. Users may not notice when you have it, but boy, do they notice when you don't have it. Every time your service has an outage, you burn away some of your users' goodwill. Do this too often, and your service will be too frustrating to use, and your users will go somewhere else. If you want to keep your users, even if they're purely internal to your own company, reliability is key, and it's definitely not free. Reliability takes a lot of work. And I've not even heard of a 2.9 service, like just 99% availability. Not even that stays up without constant engineering effort. So that's what we're going to talk about today, what you can do to keep things up and happy. So we've already established user happiness is important. Let's graph it across the timeline of an incident. So your service has a level of reliability, the border between the blue and the red areas of the graph. That's still kind of blue. That when you go below it, your users will be unhappy in some sense. Does anyone know what this level is called? Anyone out there? Have you heard of it? I'm sure we've mentioned it today. What was that? SLO, that's right. Your service level objective. 5 points to Gryffindor. That's an S, just a little bit off the screen there. Now, usually the further below your SLO that you go, the unhappier your users become. Above the target level for your SLO, and this is really the amazing part, your users become indifferent to your reliability. You can be hovering just above the red or way up at the top of the graph, and your users just don't perceive any real difference, at least in the long run. I mean, you're not going to stop having problems, and users will still see those blips. But as long as, on average, you're above that level, then your users won't feel like it's that bad of a deal. So the blue area up there, that represents your error budget. When people say, don't sweat the small stuff is what fits up there in your error budget. You can use it like what Gary was just talking about for fault injection. This is where you do your testing. When you're still up in that blue area, that's what you can use it for. But that's kind of a different topic from what I'll be talking about. I'm focusing today on keeping you out of the red. So what's happening in this graph? Well, not much yet. Let's say it's the user happiness graph for a chat app, because Google loves chat apps, and we love building graphs for chat apps. So we start off nice and high in the blue region when, bam, an outage begins. Maybe the release we just pushed is overloading a dependency. Maybe some developer added a log statement to a hot path, and I/O is blocking. Something bad happened, and it's getting worse. Now, the SREs on call for this service are blissfully unaware that anything is wrong at this point. In fact, they just went out to lunch as usual. In the meantime, though, your users are starting to get a little annoyed, but their patience hasn't run out yet. Once enough errors have accumulated, the alerting system decides it's time to page the on-call, who checks her phone, acts the page, stuffs a little more food into her mouth, and hurries back to her desk to find out what's going on. Now, this is a particularly bad outage, so we're starting to dip below our SLO. And if you check online, maybe you'll start seeing a few complaints pop up here and there. So it takes some time for the on-caller to figure out what's wrong, but they figure it out. They mitigate the problem, and your service starts running reliably again. So now, your users are starting to forget about the outage. You know, it was bad, but they got through it, and now things are okay. And the longer it stays okay, the better they're going to feel about it. But, you know, it never stays that way. And once you have another outage, then you might take another hit. Now, of course, you want your users to have the best experience. So let's look at this graph and break it down to the parts you could improve. You want to minimize your time to detect, this part, and the time to repair, this part, while maximizing the time between failures. Now, that's all pretty obvious. But think about how this graph changes if the time to detect or the time to repair were shorter, or if the slope of the graph during the outage were less steep, or if you had longer to recover before the next outage began. You'd have much less danger of dipping back into the red. This is what I mean by shrinking here. If you reduce the duration, impact, and frequency of production incidents, it helps keep your users out of the unhappy red zone. So how do you know how much to invest for improving each phase? Which phase do you target first? And where do you get the data for analysis? So 3 is a magic number, right? These 3 things underpin everything I'm going to talk about today. Number 1, of course, and you've heard a lot about these, SLOs. You have to create and maintain SLOs for your service. They're the basis for your error budgets. They define the desired measurable reliability of your service. And they affect the entire incident cycle because they tell you when something is bad, and more importantly, they tell you how bad it is. Number 2 is postmortems. You have to write postmortems. Postmortems are all about how to make things better the next time. So when do you write one? Every time your SLO takes a hit, write a postmortem. Sometimes something happens where you get lucky and your SLO didn't take a hit, but it could have. You still want to write a postmortem then because you don't want to depend on luck to keep your service reliable. It's the SRE motto. You see it everywhere. Hope is not a strategy. The reason we're talking about postmortems here is because they record what happened, when it happened, and why it happened. I'll be talking more about them later, but you know, this is a very fundamental thing that we have here. And finally, if you want accurate data, it really, really helps to have a strong, blameless culture. A blameless culture knows that whatever you did, there's probably something better that you could have done. You know, everybody's had that feeling. You're trying to handle something. Hindsight is always 20/20, but you don't have hindsight in the middle of an outage. Whatever you do, it made sense to you at the time, and you did the best that you could. If it's hard for you to figure out what to do, or if it's too easy for you to do something counterproductive, it's the system that should change. You should not be held responsible for doing the best job that you could with the information and the tools that you had. A blameless culture is essential so you aren't afraid to reach out for help during the outage. And you can be honest and open in the postmortem. This makes the postmortem actually useful as a learning tool. I mean, here's the thing. If you don't have a blameless culture, then you're living in fear of what? Blame. Your primary motivation becomes to avoid blame, not to help your users. It's to protect yourself, to protect your coworkers. I mean, would you really dive in and try to find a root cause if you think that the results of my research could get someone fired? You know, that's not the environment that you want to live in. That's not going to help anybody. So a blameless culture, a postmortem built on the blameless culture, and SLOs to underpin it all. These are the 3 fundamental pillars. So remember these as we're going through everything else. Okay, so you've got your SLOs. You know if you need to shrink to keep your users happy. And you've got your blameless postmortems, so you have a clue where you need to shrink to keep your users happy. Now, what do you do to shrink to keep your users happy? I mean, you know overall what you want the graph to look like, but let's zoom in on each phase and figure out what kind of tasks we can focus on to bring each of them under control. Now, nothing I'm going to talk about here is revolutionary. I'm sure everyone here has heard of everything I'm going to say, and you know they're all important. But what I'm trying to do here is relate each task to which phase they affect most, so that once you figure out where you need to help yourself, you can then look and say, okay, these are the kinds of things that we can work on, and this is what's going to be the best benefit to our team. What I want you to think about as I go through the next few slides is how is my service doing here? How does this apply to me? Where can I invest more? Where is it going to help me most? And at the end, we'll have a Q&A, and we can go deeper into whatever questions you have. I should really note, though, that even if you don't already have a blameless culture or postmortems or even SLOs, all the stuff in this presentation is pretty fundamental. So you can use it as a checklist to get like an instant readiness assessment of your service. And they're all need to do. It's just how much you need to do each one. And then you can use future postmortems to focus in on the ones that help you most. All right, let's get started. So you're having an outage when your error budget starts burning so fast that if you ignore it, it'll burn away all the remaining budget. You can see there in the yellow box, that slope is definitely going to intersect with the red really soon. So that's the condition that you have to fire your alert on. The time to detect is from the start of the outage to when a person that can actually work on fixing the problem is alerted. Remember, as a person on call for a service, you can't even begin to think about mitigating an issue until you know it's there. So some proactive work here is required. You really don't want your first postmortem to say, service died, nobody knew, we lost a lot of money. It's not a good way to go. All right, so we have another good rule of 3 here for shrinking time to detect. First off, you need a good signal-to-noise ratio for your SLI. That's your service level indicator, what your SLO is based on. You know whether you have a problem because of your SLIs. Good SLIs only move up or down when your users are actively getting happier or sadder. If this isn't true for the SLIs that you have, you need to fix them. Since you really only want to alert on problems that your users actually care about. So make sure your SLIs map very well to how your users are actually feeling. How do you do that? Well, you have to have some backup way to figure out how your users are feeling. Internet complaints, service calls, phone calls from angry customers. Something to tell you that I'm in the red and they're calling me. That's a good signal. I'm in the red and no one's calling me. Maybe your SLI is too sensitive. Maybe like you have a lot of jitter in your SLI and you can't use it very effectively. Like a lot of people have like a batch process that will hit their service really hard for 5 minutes or 10 minutes at midnight. You don't really want to have a bunch of errors showing up at midnight for a batch process that you control and have it page all the people on your on-call service at midnight. So maybe take that traffic and split it off to a separate SLI. Or some people have SLIs that have all errors returned from a service counts against their SLI. But 400s, 404s, maybe they don't care about those. Maybe that's not a good signal. So, where are we? Yeah, so in the beginning, for your SLIs, it's most important just to have something, and then iterate, iterate, iterate. Every time you have a postmortem, look back on it and think, how did my SLI teach me about what's actually going on in this outage? Is it worse than what the SLI said? Tweak it. Is it better? Go back the other way. Am I measuring the wrong thing? Go back and make a different SLI. All right, the next is, so you have your SLI actually reading something. You actually have to get your readings fresh so your alerting system can do something with it. This means that you'll actually get your alerts before everything explodes, hopefully. One company I worked for generated all their metrics from analyzing logs. Now, this worked out pretty well for them analyzing historic behavior, but it introduced a lot of latency for their actual alerts. So we helped them move it from a batch log processing system to a streaming metrics collection system that goes directly from their service process to the metrics backend and is analyzed in line. And this helped them get a lot of that latency out. So the final element of shrinking time to detect is the alerts themselves. What does it mean for an alert to be effective? Effective alerts are user-focused, sensitive, actionable, and delivered appropriately. Now, I'll go through that one by one. You want user-focused alerts that only fire when users are actually being affected. This is where your SLO definitions come into play, like I said. If your SLOs are user-focused, then your SLIs will be user-focused, and your alerts will be user-focused. They all fit together really well. If you base your SLI on some indirect metric like CPU utilization, it's not a good signal. It's a very low signal SLI. Sometimes it means something, sometimes it doesn't. You want your alerts to be both sensitive and actionable, but it's hard to get them both at the same time. Alert too quickly, and you'll be paging at midnight for something that goes away in seconds, and your uncallers will start looking at it, and they'll see it's already gone away, and they'll be annoyed. But if you alert too slowly, then you'll be wasting time that you could be using to mitigate real outages. It takes some analysis and time to find the right balance. It's also important to make sure the alerts get to the right person. Smaller companies don't have as much of a problem with this if they only have one on-call team. But larger companies that have multiple on-call teams, you need to make sure you loop in all the right people as fast as you can. If you can do any kind of automated root cause analysis and automatically bring those people into the alert, then that will save a lot of minutes as you're trying to get things figured out. Finally, and this is important, make it loud. Use a service like PagerDuty, OpsGenie, VictorOps, FireHydrant, something that sends alerts as a phone call or a page. Don't just use email. I repeat, do not just use email. Email is to be ignored. That's all it's good for. I repeat, it is not good at all to use email. The time will come when the person on call for your service has got to take a shower or eat dinner or go to sleep. And very few people check their email while doing these things. So with these three, your time to detect will be in pretty good shape. So shrinking time to detect was all technical tasks. Shrinking time to repair, though, is mostly about people, policies, training, and most importantly, stress management. Even if you alert super efficiently, what good is it if everybody panics when you get the alert? In my opinion, this is the most important section to focus on. You'll always have outages. They're not going away. You can automate fast solutions to many of these, but not all of them. You hire engineers because they're smart and creative. And they're ultimately the best resource you have for fixing the problems that slip through the cracks. Of course, they're also the slowest mechanism you have for fixing the problems. But they're your last, most capable defense, and it pays to prepare them properly. So a quick reminder before we begin this section. An incident responder's first duty is to protect the user and the user's data. During your outage, keep your focus just on that. Don't go and try finding all the causal factors. It just doesn't help at that point. So a good response is a temporary failover, a version rollback, an emergency request for more resources. That's all good. A bad response, go into the code, debug it, fix it, check it in, build a new release, push it out. That takes way too long. You don't have time for this. Do that later when the service is not actively burning. So what can you do to improve your time to repair? First, you have to train your responders. You need emergency procedures defined and tested so that everyone involved can be calm and productive during an outage. You need procedures that provide enough structure so that it's all organized and people know what's going on. But you need them to be flexible enough so that a lot of ad hoc debugging and impromptu substructures can take effect. And don't just train the people on call. Train everybody who might participate in incident response. Devs, product managers, project managers, even CEOs. Anybody who might contribute and have to make some sort of call. And don't train them just once. Incident response training gets rusty really, really quickly. To keep it fresh, a lot of teams at Google run weekly failure drills. We call them wheels of misfortune because we choose somebody at random and make them try something, like fix some sort of problem in production. We call them volunteers, but we put that in quotes because they're more voluntold what to do. So they go and they're given some sort of alert, and they talk through the steps, what they would do, and then another member of the team, someone who organized the drill, will play the part of any external systems or external teams that are contacting with them. A simple example could be an alert comes in that users can't log into your service. What do you do? And you go talk through all the tools that you use, all the things that you investigate, and all the people that you contact. You can also hold practical disaster recovery tests, where you actually engineer real controlled outages and then mitigate them. This is a lot what Gary was talking about in the last presentation. This gives everyone practice with actually communicating with each other and, among other things, tests all your escalation channels. You can get the whole company together to do a whole company drill like this. Something that, a scenario that Google likes to run is pretend that California had a major earthquake and slipped into the ocean. So Google headquarters is just gone. What does the rest of the company do to continue functioning? And we do this almost every year because it's important to figure out how you'd continue working if your headquarters just disappeared. Number 2 here is that you have to write alert runbooks. Some people call them playbooks. A runbook is the first thing that an uncaller sees when they get an alert. You need to write one for every alert that can fire. Write down things like special response procedures, links to dashboards, what queries you would run in the debug logs to find more information. Everything someone who's trying to handle the alert would like to know. I mean, I'm not saying that you need to know every possible cause and fix before you even write an alert, but the runbook should give you some sort of clue for how to start the investigation and where to go for help. Now, something I see a lot is someone writes a runbook, but then nobody else can understand it. Don't do this. When you write a runbook, even if you think you're just writing it for yourself, keep it brain dead simple. Write it for a version of yourself that just got back from vacation and has completely forgotten how to do everything. This is actually a good opportunity for a failure drill. Give the runbook to an alert, or give an alert for the runbook to a volunteer and see if they can follow it. Is there anything that they needed to do that wasn't in the runbook? Add it to the runbook. It's just way too easy to forget simple basic steps in the stress of an outage. So next up, you need to create a pager SLO. So this is different from your service SLO. This is the policy for how long it can take for the person on call to start working on a page. Regardless of what you actually set it to, it'll help even out your time to repair. It'll become more consistent, and that's a good thing. But what do you set it to? I mean, it's easy to think, duh, just start working as soon as you get paged. But it's not quite that simple. Say you set your pager SLO to something short, like 5 minutes. Excellent. Your average time to repair just went down. But what's the cost? It's easy to meet a 5-minute pager SLO when you're at the office. But what about the evenings, the weekends? If you're on call, you can never be more than 5 minutes away from your work computer. Grocery shopping? No way. Going out to the park for a picnic with your family? It's not going to happen. I mean, you can bring your laptop, but you have to think, what's it going to be like trying to solve a real problem with your laptop going through your phone and going over a slow connection? It's not fun. There are some teams at Google that do actually have a 5-minute pager SLO, but many teams find that 30 minutes is more reasonable. Think of your pager SLO as your jumpiness factor. How jumpy do you need your on-call team to be? I mean, choose this carefully. It's going to determine how quickly you get started on incidents, but it's also going to affect people's lives. In the same theme, actually very much the same thing, you want to start to reduce responder fatigue. As you might guess, burnout is a real problem. Being on call is a hard job to do. If you want to keep your on-callers on the team that they're on call for, you better make their happiness a priority. You can automate routine operational tasks. This takes a lot of the load off their everyday life. We call this eliminating toil. A classic example of this is release management. How much of the release can you automate so you don't have to babysit it and click buttons every half an hour? You can get more people on the rotation, so your turn for on-call doesn't come up as often. At Google, there's a general rule for 6 people minimum on a rotation. You might not actually have that many SREs, but if you're short on that, then pull in some devs. You know, some senior developers make really good on-callers. And remember, you're never alone. So if the primary on-call doesn't know what to do, there's always someone else on backup that they can contact. This is always a fun one. Get rid of unactionable alerts. You can tune them to be more effective, but maybe you can just delete them. I can tell you that there's no greater joy in an SRE's life than proving an alert is useless and then going and deleting it. We always throw like a little celebration whenever that happens. And finally, you might be able to relax your SLOs. This can be your pager SLO, so you don't have to be so jumpy all the time, even when you're not getting pages. Or it could be your service SLO. I mean, do you really need all 5 nines? Maybe not. 5 nines is hard to hit. Maybe 4 nines, 3.5. Anything that brings it down a little bit and still keeps your users happy will make life a lot more bearable for the people that have to support it. But wait, there's more. And this one's important too. You need to make sure your responders are empowered to do the job that they're paid to do, both technically and politically. All right, what do I mean by this? I mean you should make your uncallers have authority during outages. Give them control over the system that they have to fix. You don't want the outages to go on longer than they have to because your uncallers have to go call up the CEO and ask for permission to do something, or go and try something that's really important, then find out access denied, and they have to go and find out why their access is denied. It delays everything, and it's not good for your users. And you also have to make sure that everyone else who's working on the incident understands that when an on-call asks you to do something, you do it. The flip side of this is that you need a solid audit logging framework, so everyone is still accountable for their actions. Remember, blameless does not mean invisible. Another way for you to speed up your response is to improve your recovery tools. If you know what you need to do right away, but it takes forever to get it done, then maybe you need to work on this. You can start by writing tools for fast rollbacks, because that's the first best thing that any incident responder can try to do, is roll back the version that just went out, because that very often fixes the problem. Or automated failover. When something goes wrong in a particular part of your application, can you just fail over to your backup somewhere? This is very dangerous to do manually. You want to automate this as best you can. And this comes up all the time in postmortems. When you write about what you can do better next time, think about what tools you've used and what processes can be made faster. And you need good monitoring. When you get a page, the first place you go is the runbook, but the second is usually the monitoring. You want to see visual time series graphs for all of your internal metrics. These are not the SLIs. This is stuff like error rates to backend services, queue depth, memory pressure, all the technical details of your system that give you a clue of where to bring your investigation next. And finally, you need queryable logging. Like monitoring, you need it when investigating an alert. It should tell you the error details for what's going wrong. And if you ever can't get the details this way, say so in the postmortem so the devs can go in and add the lines so that next time it won't be so bad. You have to make sure that you don't have too much logging, though. Every line that you log has a cost, and you don't want to overload whatever system you're using on the back end for logs management. That can get very expensive, too. So try not to go overboard with your logging. You also need to be aware of user privacy issues. You can't just log username and all the data that goes along with that. Talk to your legal team about this and find out what you can actually record and how fast you need to delete it, because this can be a really big issue. And it's obvious, but I still have to say it. Do not write passwords to logs. It never ends well. Okay, so you've mitigated your outage. Good job. Your users are slowly rebuilding their confidence in your service. You want this phase to last as long as possible, right? At Google, we found that the most common trigger of outages is a code or config change. So to maximize time between failures, just eliminate all changes, right? Well, that might work for a little while. And actually, sometimes it's a really good idea. Like, say you have a business that gets almost all of its revenue in one particular weekend. Maybe don't make any changes during that weekend. Why take the risk? There's no purpose. But in general, you don't want changes to stop. There are always features to push, bugs to fix, new hardware to support, new threats to counter. Changes, however, can be made safer, and that's what we'll talk about here. But first, let me go back on what I said a second ago. You don't necessarily want this to last as long as possible. There are some companies I've worked with that are just laser focused on this section. They think just no outages. The best way to go is just no outages. But it turned out it was the wrong thing for them to focus on, and it's probably the wrong thing for you to focus on too. I'm not saying don't focus on it at all, but do not focus on this to the exclusion of everything else. I mean, what happens if you go too long without an outage? your on-callers get out of practice. And when you finally do have an outage, and you will, what do? They have to go and look back at the procedures. They don't have the muscle memory to figure out what to do. And everything ends up being much worse than it would have been otherwise. Also, companies that prioritize time between failures too highly often slow the release process down to a crawl. And this is bad for a number of reasons. It's bad for dev velocity, and it's really bad for response time to market forces. When things happen in your competitor companies, you won't be able to respond as quickly. In general, it's better to focus on shrinking your time to detect and your time to repair, and just take this as you need it. But that being said, most of us don't have the problem of having too few outages, so we still need to work on this stuff. Number one is our old friend, the blameless postmortem. Write one after every incident to capture metrics and analyze how things went. And most importantly, you discuss action items to make it better. And also, most importantly, make sure you do the action items. I mean, these are just not to be written and ignored. Make sure they get prioritized very highly against the other features that devs are working on. Postmortems are the key to preventing the same incident from happening twice, or at least making it better when it happens again. Remember, there's always going to be new kinds of postmortems, and you can't afford to let them build up. You should write your postmortems collaboratively with everyone else that is involved to get all the different perspectives and all the different viewpoints. And so everyone can contribute to saying, this is what I thought was going on, and this is why I did what I did. It's not that complicated. They sound hard, but they're really not bad at all. It's just a fact-finding document and a little bit of this is what I was thinking. If you've seen the Google SRE book online, there's a sample postmortem in the back, and you can use that as a template. Next up is CI/CD. You heard about this earlier in the day too. That's continuous integration and continuous delivery. This is how you can deploy changes with reasonable confidence that they won't blow up in prod, probably. I mean, sometimes they blow up anyway, but this will help them become smaller and less impactful. You need to automate your tests, unit tests, integration tests, end-to-end tests, and rerun them really often to catch regressions. At Google, we basically run every related test on every code change, and we simply block the change from ever being committed if it doesn't pass all of our tests. This is a high bar to pass, but it also it gives us a lot of confidence that when we put code out, it's not going to blow up. And you want continuous delivery, so you can get new code out as often as possible. This way, each release will be nice and small, which means smaller things can go wrong. It's much easier for you to figure out what is going wrong when there's only a few changes per release. Now, I want to talk about something really important with continuous delivery here, and that's gradual rollouts. Gradual rollouts allow you to discover problems and roll back before all your users are affected. The alternative here is just shipping your entire binary and putting it out to all services at once. This gets the new code out there quickly, but if there's a problem, you're now 100% down. A gradual rollout will only affect a few people at a time, and you can compare the error rates for those few people against the control, who are the people on the previous version, and see if those error rates, the percentages, increase. And once you have a good statistically significant number of them, you can say, okay, we're reasonably confident this new release is bad. Let's roll it back, even though we haven't fully rolled it out yet. It saves a lot of your error budget. It makes that slope of the graph at the beginning go down a lot more gradually, and that's a very good thing. We call this canary analysis. All this filters back to the dev side as well. Since there's always two active versions of the code in production, you need your data structures and all your code to be both forward and backward compatible. Why both forward and backward? Because you may get partially rolled out, change some of your backend data, and then roll back. So you need your previous version to be able to read the data written by your next version, and vice versa. So whenever you make a change, make sure they can read up to 2 versions back. And whenever you're expecting a change to be there, make sure it's there for at least 2 versions before you change it. Next is about your service architecture overall. So what makes an architecture robust? Your architecture is robust if it continues serving your users despite significant internal failures. Think redundancy, no single points of failure, graceful degradation. This means reduced functionality in when there's an outage instead of no functionality when there's an outage. Like, for example, if you serve some data gathered from some backend, and that backend goes down, the page that you display to users can still successfully be shown to users, but maybe with stale data, or maybe just not without that particular piece of data. Make sure you write your user-facing code such that it can handle partial completions from the backends. And finally, chaos engineering. You hear about this a lot nowadays. Now, I want to say I don't really like this name, and Gary said this before too. We're not trying to create chaos. We're trying to create resilience. You know, whenever you see the word chaos engineering, think resilience engineering. Anyway, why use it? It's so you can find problems under controlled conditions, so you don't find them in uncontrolled conditions. If you think your architecture is robust, poke it and verify. When I talked before about disaster recovery training or testing, it was for training the people, but you can also use it to test the systems this way. And the cool thing is, it can all be automated. Just write a test to break something in production, and what do you expect? You expect that nothing happens, at least to your users. Internally, things might be happening all over the place. You automatically fail over, your redundancy kicks in. This is all expected, but your service remains within your SLO, and that's the important part. Sometimes it doesn't. Sometimes you find a real problem, but that's why you do this in the first place. So, what are the most important things that we covered today? I mean, pretty much all of them are ignore at your own peril, but I think the most important ones are the two at the top, SLOs and blameless culture. This is what underpins everything else. Your SLOs give you that common language to say, we're out of SLO, we need to freeze. You, the PM, you told me in the beginning what you need the user reliability to be, and we're out of that. So you, as the PM, need to work with the devs to say we need to prioritize the reliability to get back up. Your SLOs are your main force of communication across different disciplines. And blameless culture, so you can make things better, so you can communicate, so you can work together and not be in fear of each other.